Alright, so my name is Nathan, and I will be joining Jonathan and Adrian, and we will be discussing the topic of machine learning. Machine learning is a very interesting topic to us. I think it'll be interesting to y'all. Machine learning is actually not too new, but it is very advanced. And you see machine learning in Alexas and in your iPhone and all types of stuff. So let's dig into it. Yeah, that's me. What is machine learning? Machine learning is a combination of algorithms and statistical models that computer systems use to perform a specific task without being directly told to do it, without explicit instructions. So, it obviously has a task, but it will pick up on habits, on different user controls, all types of stuff, so that the computer, quote unquote, kind of gets smarter and is able to deliver quicker and come up with more results based on previous inquiries, so to speak. Why would we want machine learning? Why would we want machines to get smarter? We've all seen iRobot. You don't want these machines getting too smart and taking over. Well, in my opinion, we always got the power. We're always able to pull the plug. But machine learning is very good for our future, in my opinion, because what it does is it develops systems that can automatically adapt and customize themselves to individual users. So, for example, when you're talking to Siri on your iPhone, the more you talk to Siri or Alexa or Hey Google, it learns your voice, it picks it up, and that way it can deliver your answers quicker. And it's all for efficiency. Machine learning is getting better every day, and it's getting more complex, and it's picking up on stuff like the weather, and based on patterns, history, stats, data, combines it with the algorithms that humans actually create, and it comes up with these results that are fairly accurate. It also has the ability to mimic human and replace certain autonomous tasks which require some intelligence. It's like weather or, complex math problems. Like IBM had that one machine that could outsmart anybody. That was machine learning. Machine learning, the thing is with machine learning, there is a significant difference between machine learning and AI. And we will be getting into that very shortly. One of the earliest forms of machine learning was actually in the 1950s. It was a checkers robot, so to speak. It was to play checkers, and it was an algorithm that a man by Arthur Samuel created using the alpha-beta pruning or minimax method. As you can see up top, that's the minimax alpha-beta pruning method. It's basically a process of elimination and determining what the opponent will be doing next. And what was a big deal about this, it wasn't the machine itself that was revolutionary. It was the software that he created that was able to be pretty universal on a lot of other machines. So this is what was very significant about Arthur Samuel's creation, is that they were able to grab that software and start putting it in other machines and making it more complex. Interesting stuff. So I got a little video here for you. Difference between machine learning and AI. Some people get it twisted, so to speak. So we'll go ahead and check this out.
device that perceives its environment and takes actions in order to maximize its possibilities of success can be said to have some kind of artificial intelligence. More specifically, we can say that AI exists when a machine has cognitive capabilities, such as problem solving and learning, for example, usually associated with a benchmark, the human level in terms of reasoning, speech, and vision. So we can say that AI has three different levels. Narrow AI is when a machine can perform a specific task much better than a human. Here is where we still are nowadays. General AI, when a machine can perform any intellectual task as a human would perform. And strong AI, when machines can beat humans in lots of tasks. One of my favorite early developments in AI is the perceptron. It was a single-layer artificial neural network designed for image recognition in the late 50s. But why are they called neural networks? Because the first practitioners of AI thought that these interconnected nodes looked like the human neural system. We, humans, have neural networks in our nervous system, and these are the natural neural nets, while the perceptron is a rudimentary version of the artificial ones. As a subset of AI, we have machine learning. This is where, from the 1980s, a body of research in supervised learning has flourished. This is when algorithms are trained and learn from past examples in a model that maps features to a corresponding outcome variable. Here, we rely most of the applications of AI for business, which we covered in one of our previous videos. So follow the link in the description if you want to know more. And finally,
So basically, machine learning is a subset of AI. Like I said, it learns from the past and it continues to build off that, basically coming down to a yes or no answer. So machine learning is a subset of AI. Machine learning counts as AI, but not all AI counts as machine learning. Machine learning is an application of artificial intelligence that provides systems with the ability to automatically learn and improve from experience without being explicitly programmed. So these algorithms are what are helping the machine learn instead of humans or users inputting that information. As you can see, artificial intelligence is a program that can sense, reason, act, and adapt. But machine learning, algorithms whose performance improve as they are exposed to more data over time. More data equals better performance. So in the late 1970s, early 1980s, machine learning and AI part ways. So AI focused on using logical knowledge-based approaches rather than algorithms. Machine learning was actually a way to train AI.
Everybody, my name is Jonathan, and I will be covering the machine learning process. So, as you can see in the chart on the right, the machine learning process could be simplified and in these few steps. So, the first step, you must have your training data, and the training data you'll use it to create your model, and that you'll use for prediction. And as you use it, it will keep on updating and improving. The training process is a little bit more complex. So it always starts with the data, and then you can and then after that you move on to the pre-processing phase where you can use normalization or dimension reduction, depending on the learning methods that you choose to use. As for learning methods, we have supervised, unsupervised, and reinforcement learning that we'll be covering in the next few slides. And always at the end of the training phase, you always have the error analysis part, where you make sure that your machine learning model can actually accomplish the task that it's supposed to do. All right, I'm gonna start talking now about the learning methods, starting with the supervised machine learning. Which is typically done in the context of classification and regression. Classification is when we want to map inputs to outputs labels, and regression is when we want to map inputs to a continuous output. And as you can see in the slides, all images of Toms and Jerrys are actually labeled from the beginning, and the machine gets trained using these labeled data. And towards the end of the training phase, you'll see the model evaluation, where you will have to use pictures of Tom and Jerry that you did not use at the beginning, to make sure that the machine learning could actually group Tom and Jerry in different classes and be able to to do that without any problem. And it will also give you correctness level, like a correctness rate, like in terms of percentage. So if it can predict what terms the actual terms are and the Jerry's are without any problem, it will get the correctness rate will be all the way up, and then you may start using your machine learning model without any problem. And also the outputs will also be something the machine learning will know exactly what the output is, because it will be like, hey, this is a picture of Jerry and this one is one of Tom. Unsupervised machine learning, it's usually used in the context of clustering and representation learning, and also in the density estimation. As you can see in this picture, the training data they are not actually labeled. So the machine learning will actually analyze those data and find similarities, and that way it will use clustering methods to group them in separate classes. And always at the end, there's always part where you have to evaluate your model and make sure that it works as intended. And the output of the machine learning model will be unlabeled data, but it will be all separated in the correct class. For example, the machine learning might notice that all Tom pictures are actually gray, and all Jerry pictures are brownish. So just with that one feature, the machine learning could separate them easily. Many people don't cover reinforcement learning, but it's actually something that also it's actually one of the learning methods for machine learning. And in this one, it's neither supervised nor unsupervised. The next picture actually explained it way better than I could ever do. So as you can see in this picture, we have a dog. Before conditioning, the dog look at the food and automatically start salivating. And also, whenever the dog listens to the bell, it doesn't do anything, no salivation at all. But during conditioning, you train the dog to salivate whenever whenever it sees food. And after the conditioning, the dog will be salivating as soon as they hear the bell, even if the food is not there. So the reinforcement learning works with rewards. It's a rewards kind of learning. As a machine learning will predicts correctly something, automatically you can deduct, you can add points, or you can deduct them if the machine learning does not predict correctly. That way, every time that you let the machine learning know that it didn't do it right, it updates itself and learn from those mistakes, because it always wants to gain more points and all that. And so it's not supervised because nothing is labeled at the beginning, and it's also unsupervised because from the beginning you have to program what the reward will be. So it's not unsupervised neither. Now we will move on to the three big techniques of machine learning. If you do your own little research, you might find out that there are actually many other techniques, but these three actually groups all of them. There is random forest, support vector machine, and neural networks. Random forest is a supervised machine learning algorithms, and the name forest comes because it's actually a collection of many hundreds of thousands of decision trees, and those decision trees are usually trained with the bagging methods. The general idea behind the bagging methods is that the combination of learning models increase the overall results. So random forest is flexible, easy to use machine learning algorithm that produce a pretty great results most of the time. And it's also mostly used because of its simplicity and diversity. Here are some examples of decision trees. You start from the top and you move on to the bottom. Everybody have seen this since middle school or even earlier. All right, in this slide, we kind of dissect one of this decision tree. At the top, we always have the root nodes, and then and the following nodes will be inferior nodes, and also the leaf nodes are the decision points. Support vector machine, also called support vector networks, actually started in 1960s with two PhD students, Vladimir Vatnik and Alkesi Chervonensky in Russia, and it's actually a supervised learning model with associated learning algorithm that analyze data used for classification and regression analysis. Um, Given a set of training examples, each marked as belonging to one or the other two categories, uh, support vector machine uh, support vector machine builds a model that assign new examples to one of the two categories. So SVM, support vector machine (SVM) would map all the categories features of each group and into space and finds the optimal hyperplane. As you can see, the hyperplane is the line in the middle separating both classes. So the two classes, the red points and the blue points are the two different categories, and whenever you bring new data to this machine learning model, it will try to determine if it's whether a blue point or red point. And the way it does that, it's by finding the upper plane and making sure that all the margins are maximized all the way to the closest red dot and to the closest blue dot. And those dots on the edge are called actually support vectors. And that's exactly how they actually draw that vector. So you have to find first uh, those features that are on the edge, and where you can write the vectors and by maximizing the margin for the upper plane. Also, but the first example that I just showed you is pretty easy because it's super clear and it's all linear. But sometimes you might have a non-linear problem, and in these cases, what you need to do is you need to move into a higher dimensionality. You can, i.e., create a new feature as a function of the existing features. And when you move from a 2D from a 2D dimension to a 3D dimension, it can this could be pretty expensive on a computational level, and that's exactly when the kernel tricks comes in. So the kernel trick the kernel trick allows us to operate in the original feature space without computing the coordinates of the data in a higher dimensional space. And if you look at the footnotes of the presentation that I offered, you can see a link that can take you that can give you access to more information about the kernel trick. Neural networks are actually a set of algorithms modeled loosely after the human brain, and they're also designed to recognize patterns. They interpret sensory data through a kind of machine perception, labeling, or clustering raw inputs, which makes it a non-supervised learning algorithm. Dr. Robert Hecht Nielsen also defined neural networks as a computing system made up of a number of simple, highly interconnected processing elements which process information by their dynamic states response to external inputs. As you can see in the picture on the top, there's a human neural network um, picture, and on the bottom there is the math version of that same neural network. And the human brain consists of 200 billions of neurons, and neuron is and the specific neuron is formed from four basic parts, as the dendrite, soma, axon, and the synapses. The neuron collects signals from dendrites, and the soma cells sums up all the signals collected, and when the sum reaches the thresholds, the signal passed through the axon or to the other neurons, and the synapses indicated the strength of the interconnection in between the neurons. And as you can see in the math model too, we have whatever represent the axon, the dendrites, the synapses, and also we also have extra stuff like the activation function. There are so many forms of the neural network, and we have the neural network zoo. I can click on it here. It takes us to this website, where you can see also so many neural network forms. And I also post the link to this web page under the notes of the slides. Deep learning architecture neural network is all about deep learning. You always have a deep learning architecture, and whenever a neural network has more than one hidden layer, automatically it's a deep neural network. And every node in one layer is connected to every node in the next layer and in the next layer, and it keeps going like that until the output. And I have this video right here. I will only play 3 minutes of it, but I highly suggest for you to watch the entire video, and also to watch the entire series. I also posted the link to all these videos. They are very informative and fun to watch. Let's go.
This is a 3. It's sloppily written and rendered at an extremely low resolution of 28 by 28 pixels, but your brain has no trouble recognizing it as a 3. And I want you to take a moment to appreciate how crazy it is that brains can do this so effortlessly. I mean, this, and this are also recognizable as 3s, even though the specific values of each pixel is very different from one image to the next. The particular light-sensitive cells in your eye that are firing when you see this 3 are very different from the ones firing when you see this 3. But something in that crazy smart visual cortex of yours resolves these as representing the same idea, while at the same time recognizing other images as their own distinct ideas. But if I told you, hey, sit down and write for me a program that takes in a grid of 28 by 28 pixels like this, and outputs a single number between 0 and 10, telling you what it thinks the digit is, well, the task goes from comically trivial to dauntingly difficult. Unless you've been living under a rock, I think I hardly need to motivate the relevance and importance of machine learning and neural networks to the present and to the future. But what I want to do here is show you what a neural network actually is, assuming no background, and to help visualize what it's doing. Not as a buzzword, but as a piece of math. My hope is just that you come away feeling like the structure itself is motivated, and to feel like you know what it means when you read or you hear about a neural network, quote-unquote, learning. This video is just going to be devoted to the structure component of that, and the following one is going to tackle learning. What we're going to do is put together a neural network that can learn to recognize handwritten digits. This is a somewhat classic example for introducing the topic, and I'm happy to stick with the status quo here, because at the end of the 2 videos, I want to point you to a couple good resources where you can learn more, and where you can download the code that does this and play with it on your own computer. There are many variants of neural networks, and in recent years there's been sort of a boom in research towards these variants. But in these 2 introductory videos, you and I are just going to look at the simplest plain vanilla form with no added frills. This is kind of a necessary prerequisite for understanding any of the more powerful modern variants, and trust me, it still has plenty of complexity for us to wrap our minds around. But even in this simplest form, it can learn to recognize handwritten digits, which is a pretty cool thing for a computer to be able to do. And at the same time, you'll see how it does fall short of a couple hopes that we might have for it. As the name suggests, neural networks are inspired by the brain. But let's break that down. What are the neurons, and in what sense are they linked together? Right now, when I say neuron, all I want you to think about is a thing that holds a number. Specifically, a number between 0 and 1. It's really not more than that. For example, the network starts with a bunch of neurons corresponding to each of the 28 times 28 pixels of the input image, which is 784 neurons in total. Each one of these holds a number that represents the grayscale value of the corresponding pixel. ranging from 0 for black pixels up to 1 for white pixels. This number inside the neuron is called its activation. And the image you might have in mind here is that each neuron is lit up when its activation is a high number. So all of these 784 neurons make up the first layer of our network. Now jumping over to the last layer, this has 10 neurons, each representing one of the digits. The activation in these neurons, again, some number that's between 0 and 1, represents how much the system thinks that a given image corresponds with a given digit. There's also a couple layers in between called the hidden layers, which for the time being should just be a giant question mark for how on earth this process of recognizing digits is going to be handled. In this network, I chose 2 hidden layers, each one with 16 neurons, and admittedly, that's kind of an arbitrary choice. To be honest, I chose 2 layers based on how I want to motivate the structure in just a moment. And 16, well, that was just a nice number to fit on the screen. In practice, there is a lot of room for experiment with a specific structure here. The way the network operates, activations in one layer determine the activations of the next layer. And of course, the heart of the network, as an information processing mechanism, comes down to exactly how those activations from one layer bring about activations in the next layer. It's meant to be loosely analogous to how in biological networks of neurons, some groups of neurons firing cause certain others to fire. Now the network...
Alright, I'm going to stop here, but you can keep watching the video. All the slides are inside the comments on YouTube and also inside the class discussion board. And you can watch it on your own. I promise you that you won't regret it and you will learn a lot. So here is just a slide showing again the single layer example with math model. Machine learning tools. I also guess that it was important to mention a few tools for machine learning. And most of them are actually libraries from different programming languages. And these days, most people prefer using Python programming. So I felt the need to mention their largest machine learning libraries. TensorFlow is the biggest one, and there is also Keras, PyTorch, and I can also think about Caffe and Caffe 2, and they also have many others. It's also good to mention Microsoft the Cognitive Toolkit, which is very good for machine learning and AI. And I highly recommend you guys to just go to the Microsoft websites and check out their API. Onks is an amazing platform for AI, so it can obviously be used for machine learning too. And I also felt the need to mention CoreML and ML and the ML kit for Android. Those last two are machine learning kits for iOS and Android's development. So, and they are pretty easy to use. So if you want to play around, you can find many tutorials on Google on how to create your first machine learning application in under an hour. So please go ahead and check that out too. So I'm gonna let Adrian talk about the application of machine learning now.
All right, so on this screen, you're gonna see some of the things I'm gonna be talking about. Things like feature recognition, or how a computer looks at images and they finds patterns. We're going to be talking about natural language processing, or how computers understands human communication. We're going to be talking about marketing, or how companies use machine learning to predict potential customers, or how they improve their advertising. We're going to be looking at user behavior analytics, or how machines adjust their behavior based on what you do. And we're going to be talking about abnormal detection, or basically how a machine detects differences, subtle or big, between two different images. Okay, so first I want to start with a video about Target and how they use machine learning to predict which customers they could serve better and how it went wrong. I don't want to ruin it for you guys, so check it out.
We all know that stores know things about us based on our shopping habits.
But you know, sometimes what stores find out gets a little bit creepy. The latest, how some stores can figure out that a woman is pregnant before she tells anyone. Consumer reporter John Matteries is here now with this unusual story. John?
Well, Carol, many stores now keep a database of everything you buy. That's how grocery store registers know what coupons to spit out for you. You know, your shopper's card keeps a record of all your purchases at the grocery store. But some say it went too far when Target figured out that a teen was pregnant before her family even knew. That's right, a report in the New York Times says Target's sophisticated computers are able to guess when a woman shopper is pregnant based on 25 items that pregnant women buy. Among them, vitamins, zinc and magnesium supplements, and cocoa butter lotion. Toss in extra large clothing or a rocking chair, and the store decides you are pregnant and starts targeting you with baby coupons. But the New York Times says an irate father asked a Target manager why his teenage daughter was receiving baby coupons in the mail. Turns out his daughter was pregnant and had told no one at all, but she had been shopping at Target for products that an expected mom typically buys. How about that? The New York Times says Target's goal is to lure expected moms during their second trimester. It wants to get them to start shopping them to make Target their #1 store through their pregnancy and then once they have their baby. Is this legal? Yes, but if you find this just a bit creepy, you might want to spread out your shopping among various stores, or the simple way to stop anything like this, pay by cash so you're anonymous.
Okay, so Target's idea was they know that parents are tired and they don't want to go shopping at many different places, so they can get them to shop at Target for baby needs. They probably shop there for everything else. I don't know if it works, but that's a great use of machine learning, and maybe it helped. Alright, here we're going to be taking a look at one of the first machine learning programs ever made. It was in 1952, created by a guy named Arthur L. Samuel. It was a program made to play checkers using algorithms. Every time it played a game, it would get better marginally. After a while, he would create two programs to play each other and then scrap the weaker program for a new improved one. And eventually he would make it better and better until he thought it was good enough to play a pro player. It ended up not being better than a pro player because the technology back then wasn't up to date, but it was still an amazing advanced technique at the time, and he's probably the father of machine learning. Next, we're going to take a look at handwriting recognition, or HWR. This was basically the extension of OCR, optical character recognition. Basically, this takes a document or anything that you write on an iPad or a picture and scans it for text. Afterwards, it splits up both or all characters inside the text, and using context clues from a database that already has, tries to predict the letter. This is useful for trying to convert notes into digital forms or receipts or anything like that. Next, we have video surveillance. Basically, the problem with this before was that it's hard for one person to look at multiple screens at the same time. So the logical choice is to teach software to do this for us. It does this by looking at different movements, different things, and seeing what's abnormal or what's different than normal, and then based on that it alerts someone. So basically, if it sees someone stumbling across the floor or sleeping on a bench or staying still for a very long time, it will alert the cops. The cops can go over there and handle it. If it turns out to be a true disturbance, it could tell the system, and the system will improve over time based on what it gets right. It's very clever, very cool. Catches millions of people a year. So, awesome. Next, we have email spam filtering. This is a classic because it's one of the oldest things. Basically, the way it works is Gmail, when you receive an email, it has characteristics on it. Basically, the characteristics could be from the sender's email address, the IP address they have, or what's in the email itself. Gmail will filter that, and based on database they have of previously filtered emails, it will either mark it spam or mark it not spam and send to your inbox. Pretty simple, pretty easy, but it doesn't stop there. Afterwards, you could go into your inbox, you could flag something as spam, and next time a similar email comes in, it will automatically go to spam. So this is kind of an example of behavior analytics and how it changes its behavior based on ours. Next, we have a Google search bar. This is probably the most used application of machine learning in the world. Everyone Googles. I Google all the time, every day, all day. It does this by saving every search into a database, and based on that database, it predicts what you're going to search using factors. These factors could include what you searched in the past, popular searches in the world, or even trending searches in your geographic region. Right now, a popular example would be if you type in the letter C, COVID-19 or coronavirus will pop up very fast because everyone's searching for information on that right now. Very useful, I think. Next, we have Google Lens. This was a advanced technique. It was an application developed by Google in 2017. It advertised basically explore the world you see. It did this by using image recognition technology, and basically when you point the camera to something, it would use a database of all the images it has stored and find similar images, and based on that bring up relevant information. So an example would be on this picture, the guy pointing at a lemon, and Google Lens brought up information on lemons or mild lemons or citrons based on that because they had similar pictures. This is very useful. It could be useful for travelers in foreign countries sitting in restaurants trying to read a foreign language menu. You could take a picture of the menu and it would translate the text to your preferred language. Another application could be someone at a car show wanting to know more about a car. You could take a picture of it and Google Lens would bring up the model year, the price around your area, or just any more information you would like to know. This is one of the more modern ideas of machine learning, and I like it. I use it a lot to find out what dishes are on people's tables at restaurants. And to me, I think it's one of the cooler things. So here are just the plethora of other ways the machine learning is used, from medical diagnosis to fraud detection to self-driving cars and Teslas. Product recommendations on Amazon is used. Things that people are buying around you or things you've looked before, advertisements will pop up or recommendations will pop up of those types of items for you. Traffic predictions on Google Maps. Areas that are congested during certain times of the day will show up on other people's maps as congested based on machine learning. There's just so many different ways machine learning helps us through our day that we don't know, and it only gets more advanced every day that passes. So I'm excited for the future. Here is some more information on machine learning that I posted for you guys to learn. It's a full playlist on an introduction of machine learning. It's about 60 minutes long. It's very entertaining. I highly recommend that you guys go through it if we haven't covered anything that you want to learn about. Or if you have any more questions, feel free to post them on, our video link or wherever, or discussion board. Yeah, thank you guys. Enjoy the rest of your break. Be safe and stay healthy, guys.